a little bit of the morning trying to figure out how I wanted to start this video. And obviously this is for Mr. V, so he can kind of see what I've done and why it's done this way or how I do it. So we're going to complete one of the last machining processes on this L134 engine today. But before we do, I just kind of want to explain what is happening with the valve and in the head, and how the valve moves in the head, and why it's important when we go out to the grinder, why it's important that we're doing what we're doing. So I'm not going to take up a whole lot of time with this, but I do want to explain kind of what's going on here. So if you look, this will be the block, the engine block, and this is a valve. So the camshaft sits down here and it pushes the valve up and down depending on when air and fuel enter the combustion chamber. We'll say this is an intake valve. So the camshaft rotates, hits the lifter hits the valve, it opens the valve, it allows air and fuel to be sucked in between these areas here to enter into the combustion chamber. But when the engine changes strokes from intake to the next stroke, which is compression, this valve has to close so that it seals in all of that atomized fuel. So when the spark plug ignites the fuel and that explosion takes place, this area between the head, between the block and the seat, the area between the seat on the block and the valve face on the valve have to seal in order to hold all of that combustion gas or compression inside that cylinder. So I'm going to show you how I grind a valve seat. It may not be everybody's way of grinding a valve seat, but it works for me, and we're going to prove that by pulling a vacuum on each one of the valves to ensure that the valve is sealing before we go into the engine run-up. So what we're going to do, so what is happening here is, if you'll look, you'll see the block, and you'll see that this is the top of the block right here and how flat it is. Then you see a minor angle turn here, then you see another minor angle turn here, then the third minor angle, and then the fourth minor angle. So if you, in actuality, if you count all of the angles that contributes to getting air and fuel into the combustion chamber, there are 5, because this is an angle here, and this is an angle here. But these 3 are the ones that we are concerned with the most, simply because as atomized air and fuel enter into the combustion chamber, we want no obstructions. We want that air and fuel to flow as smoothly as we can into the combustion chamber. And that's why I like to put, well, you're supposed to put 3 angles, 3 major angles into that airflow area or into that flow chamber, so that air and fuel does not have an abrupt corner to travel. Because if air has to move around a 90 degree arc, then it's not going to flow well. And we want this engine, we want to get all we can get out of this engine. So we're going to come in here and straighten these valves out. So before we move out to the grinder, I'm just going to show you that, you know, in the TM there's a specification for how wide this angle needs to be and how much contact surface needs to be contacted on that valve. And I'll show you how we indicate that and show you how we find that. So alright, so let's move out to the engine, and I'll kind of show you what we got set up. Okay, so there's kind of some interesting things going on here. So let's take a look at this number 3 intake. intake valve. You can see right here where the air and fuel enters into the flow chamber, and the atomized fuel and air feed both of these intake valves. But we're going to focus in on just one so we can kind of see the condition of, you know, kind of what's going on here. So if you look real close, you can see that this area right here, that's the plane of the engine block. Then you see a minor angle begin right here. Then just below that you see another angle, and just below that you'll see your third angle. So what I'm going to do today is going to be called a 3-angle valve job, because we want to control how well the air flows into the combustion chamber. We don't want to just leave these at a 90-degree angle, because flow is everything with any engine. How that atomized fuel gets into a combustion chamber is very important. So we want to set this thing up, and this is time-consuming work, because each valve is different. And keep in mind, we've changed all the guides out, so that's changed the concentricity of each valve pocket. And you'll kind of see what I'm talking about as we get into how to do this. Over here I have a finished valve seat, and I have matched it to a valve, and put Dicom on here so you can see that directly above this shiny area is your first angle, and that will be 60 degrees. Then the second angle, the shiny, is 45. That is the actual area that the valve contacts the seat and seals off the combustion gases in the engine. And if you look below that, you'll see another yellow band, a red band of Dicom. That will be the third angle. And I just kind of indicated that so you could actually see the angles and why they're kind of important. So what we'll do is, I've already done this one, and I'm gonna go back and show the process of how I do this. But so I've already got this one completed and tested. So I'm gonna show you how I do this and how I assure myself before the engine goes into the run-up that these valves are doing what I have machined them to do. Because if I just go in there and put a surface on them, I don't know how well they're sealing, and I've got to ensure that they are sealing very well. So what I've done is set up a vacuum pump, and you can see right here where I have the cylinder, the flow chamber blocked off with a vacuum pump. So actually what I'm doing is pulling a vacuum on this valve and the seat to ensure that it is indeed sealing the way it should seal. So so I've got a little gauge here, and these are measured in inches of mercury, and my vacuum pump will only go up to about 20 pounds. So we'll just kind of turn it on here so you can kind of see what happens, so you can see, and then I'll show you a faulty valve that won't seal and what that looks like. So you can see immediately that the gauge jumps up to 20 inches of mercury, but I can push up on the valve and break that seal, and it goes back to 0. When I close the valve again with minimum effort, it goes right back to 20. So I know that valve is sealing properly So when the engine runs, that valve is going to hold all of the combustion gases and force them to stay in the combustion chamber until it is robbed of all the power. Because I don't want my power leaking past these valves. And if you don't do this right, that's exactly what will happen. When that explosion takes place, it'll leak past these areas here and here and will blow combustion gases into the combustion chamber, which will create blow-by. And blow-by is an indication that your valves are leaking, your valve guides are leaking, and that robs the engine of power. It also contaminates the engine oil with soot from unburnt gases. You want to contain all of that soot inside the combustion chamber and the exhaust flow chamber to keep that soot from getting into your engine. So these valves being properly fitted are pretty important, especially to a flathead engine, because of the way the fuel enters the chamber. On a flathead, since the valves are in the block, the fuel enters below the valve train. Actually comes up through the block and sneaks up past the valve here, and then has to migrate over into the combustion chamber. And this is called an L configuration, an L head, because of that configuration. Now a more modern engine, the valves will sit the other way, and they will actually sit on top of the combustion chamber somewhere in this orientation. So the fuel comes in from the top of the valve into the combustion chamber, and it's a more efficient way to transfer that atomized fuel into the combustion chamber than it is having to send it through all these flow chambers to get into the combustion chamber to complete the combustion process. So understanding that, we need to make sure that these are exactly, they're doing exactly what they need to do. Okay, so we'll move into the process so we can see kind of how this is done, and we'll go from there. So, okay, stand by. Okay, so we're going to start with the number 3 exhaust. Okay, so what I'm going to do is I'm going to take my pilot and I'm going to stick down in the hole, and that's going to center my grinding stone up on this sealing surface to make sure that it's concentric. So I've got a stone here that has 2 angles on it. The bottom angle is 45 degrees, the top angle is 60 degrees, and I've got a third stone over here that's 30 degrees. So the call out in the technical manual is that the angle between the valve face and the valve seat needs to be 45 degrees, but it also has to be a certain width. It can't be too thick. So knowing that I've changed these valve guides out, I know that they're not going to be concentric anymore with the bore, with the valve. So what I like to do is just slip my little grinder stone on here and just kind of take a slow rub by hand, so I can get an indication of how bad it's out of concentricity. And I don't know if you can see this, but in this area over here, the stone is not touching. But over here, you can see the shiny spots where the stone is touching. So we got to bring all that back in together so that I've got shiny material all around that valve face. Then we'll start working on the angles and walk them in so that it passes the inches of mercury test. So I put a little bounce spring on there, and I've got a little driver that goes on the end of the, I've got a little grinder that goes on the end of the stone, and I'm going to come in here and I'm going to bounce and just touch off just a little bit. We'll zoom in so you can take a look here. Okay, so now you can see I'm pretty much concentric. I've got new material all the way around that valve face, or the valve seat, but I only have one angle, and that's a 45 degree angle.